Okay, hi everyone. My name is Kingsley Doko, and welcome to another series on Juniper XROS device clustering. This is a continuation from where we stopped in the previous videos. If this is your first time of joining this, of watching this video is part of a series, and we started with the setup of the Juniper XROS devices. With this, the focus was clustering them, and we've looked at the overview, the nitty-gritty into the different design considerations, and how you can actually implement the XRS device. We looked at the physical cabling. We looked at the different connections that has to exist for the devices, and then of course we looked at how you can configure it, how you can test failover. There's automatic, there's manual failover. We looked at how you can monitor these interfaces. We looked at interface monitoring. We also looked at the one IP monitoring. And this video is like a wrap-up of the clustering of the SRX. So if this is your first time of joining this video and you don't really have a pretty good knowledge of how you can implement clustering, then you might want to go back to those videos. It might be very useful. But the focus of this video is how we can take, physical interfaces, put them into a RECT interface, and then put them into an LACP bundle, or like a port channel, or an aggregate interface, as Juniper calls it. So you have your RECT interface, which is you have your physical interface, right? Physical interface, and then you have your aggregate interface, which is the AE, right? In this case, we can say AE0. Okay, so we already took the physical interface, put them inside RECT interface. Now what we just want to do is put them into the aggregate interface. You and I both know the advantages of LACP interfaces, of body interfaces. There's more resiliencies on the link, and then there's increased bandwidth. Okay, so that is just what we want to demonstrate in this video. So in our previous sessions, what we only looked at they were basically physical interfaces, right? For example, I'm going to just have to zoom in into this topology so that you can see clearly. Okay, so this is our one link, right? Port 3, right? Same port 3 here. Of course, there's an offset, right? There's an offset, so it's actually 7/0/3, right? This is fabric links. We've talked about this, and this is for the management link or control plane, right? Syncing. Now, the focus is how you could have situations where you have multiple interfaces for redundancy, right? There's already redundancy here because if this link fails, what happens? There's a failover, right? And then traffic moves to the secondary, because in our implementation, this is the primary and this is your secondary, right? So there's already like one level of resilience, right? One port fails on the primary, traffic move over to the secondary per redundancy group. We've talked about all of these. But then we can enhance this resiliency, right, by taking not just one physical port per node, but multiple ports, right? And so that is what we want to look at in this implementation. So in this case, I'm not going to be doing it for the one link. I'm doing it for the local area network. Okay. Now, in our previous videos, we're only using port 4 on both sides for the connections that goes to your internal network, right? But in this case, what we have done now is that we've introduced a new port, which is port 5 on both sides, right? The both goes to this Tor switch, right? Now this Tor switch could be MC lag, it could be virtual chassis for like Juniper, it could be multi-chassis lag, maybe if it's a Cisco NSOS device. If it's Arista also support M lag, right? Where you have, multiple switches, clustered as one device. We could look at such implementation as well for it, but that's a topic for a different day. But what we are saying is that we want two physical ports, right, to be part of a RECT interface and then tied to an aggregate Ethernet interface. Now, when you have a RECT interface that is added to an aggregate interface, Juniper call it RETH LAG. Okay, we cannot say this is a RETH LAG interface. Now, mind you, we have the normal or standard lag interface, right? So if I decide to take this interface so what I'm saying is, if I decide to take two physical interface, right? So if I take two interface like this, put them in LACP, and this is my switch, right? These are physical interface that are part of what? That are added to what? An aggregate interface or LACP, right? Now, these interfaces do not necessarily have to be RECT interfaces, right? For example, if this is just a standalone firewall. So in this case, this is also a lag interface, but you don't call it RECT lag, you just call it local lag, right? Local, lag interface, because this is just your regular bond lane of interface. But in this, our implementation is quite different because we are looking at a situation where you have, of course, the firewalls are clusters, and so you need to see how we can add them to RECT interfaces. Bundle interfaces. Now, for Juniper, depending on the model, so for the SRX, I think you have the 5000 series. You have, I think you also have the 4600 series. You have the XRS 300 series. There's the I think 150M, right? There's the 1500M. Of course, there's different models that exist. Now, when you want to configure a lag interfaces for RECT, depending on the hardware model, that determines what is the minimum and maximum supported, right? Now, for high-end firewall in this category, they support up to 8 physical links, right? So 1 times 8, let's say they are 1 gig links, right? So per node, right? So the implication of this is that if this is a 5000 series device, I can take up to 8 physical ports, right? So I can take 8 from here and take 8 from here, and then together you have 16 physical port that is part of a RECT interface, right? And then that is part of a what? An aggregate interface. Okay, but for the lower end devices such as this, they only support up to 4 physical interface. So for this, you can only have 4 physical let's say times 1 gig, or depending if it's 10 gig or whatever you're doing. All right, so it therefore means the maximum here is going to be what? 8 per on. So per node is 4, then together on both clusters you can have maximum of 8. Okay. Yeah, so that is really what we need to know about clustering. Adding interfaces to RECT interface. So let's look at how do we actually implement this. Okay. So we already have, so the topology you're seeing here is like the low level design. You see, we try to show the different physical ports that are connected, but let's look at it on the high level design. Okay, so let's say I have a switch here, not a switch, the SRX. Okay, so these are my 2 boxes. This is SRX A, this is SRX B. Okay, so you're definitely going to have a switch, which is the top switch that you have here. Now the focus is on the LAN side, which is this direction. So what we want to implement is you're going to have 2 physical ports come to this switch, and then another 2 physical port comes to this switch. Okay. Now you know these two devices share the same control plane. It's not multi-chassis. There is a cluster, so they have a single brain, a single control plane, right? So what that means is these ports are all configured as one lag or one bundle. Okay, so here I have port 4 and 5. Here I also have port 4 and 5. So remember, you don't need to really specify the individual ports. The moment you add this physical port to your RETH interface, which in this case is RETH 1, right? Then on both sides, they automatically what added, right? So this is what we have. So this is it's going to be your AE, let's say AE1, right? But on the switch side, can we also go ahead and take all these ports and put them as now this is Arista, so this is the switch. Arista is also use port channel, so let's say PO1. Can we do this? Now for clustering, right? Remember, you always have your primary and the secondary. Okay, now in scenario like this, what happens is when you configure this single port channel or bundle interface or aggregate interface, depending on what you want to call it, what this Arista devices does, or the LACP D process does, is that it's going to create two sub lags. So we actually have lag, which is the active lag, and there's also the standby lag. Okay, now the active lag will be on the device that is the primary, which in this case is this device, while the standby lag will be assigned to the device that is on standby. So the implication of this is this: yes, you can configure it this way, but what will happen is, because this device is on standby, this XRSB is never going to send LACP protocol down to the switch, right? So what we end up having is that this port will remain down. So even if you configure the 4 port as part of one port channel, these 2 ports will remain down. They will never come up. So if this is a server on your data center, right, that is sending traffic to this switch, the implication is the traffic will always end up going in this direction, right? So the traffic will always end up going in this direction because these ports are down, right? Now when there's a failover, of course, the traffic will move back to the secondary. Now, Juniper's own recommendation is don't do this. Okay, Juniper's recommendation is don't configure it this way, right? Since you end up having 2 sub interfaces in the first place, right? 2 lag bundles, or how you want to call it, it is better to make this separate and then also make this separate. Okay, so this is what Juniper recommends, that you create 2 separate port channels on the switch, each facing each of the individual node in the cluster, and that is what we are going to implement. Now within your RETH interface, so I can take, let's say these are 4 links, right? We can take these 4 links, you know the process now, right? So we take these 4 links and then we add them to what? RETH interface. We say, oh, you're part of RETH interface 1, 1, 1, 1. Okay, so they are part of RETH interface, and then we take the RETH interface itself and then we tie it to the aggregate interface. Okay, now when you configure RETH interface, you have the option of setting the minimal links. Right? Now, by default, the minimal links is 1. So the implication is, if you have 4 physical interfaces and you said the minimal link is 1 for it to be active, it means if this goes down and this goes down and this goes down, right, and this eventually goes down, then it's going to trigger a failover, right? But of course, in our own implementation, we are not using we're only using 2 physical interfaces here. So I have this interface, I have this interface, right? So by default, the minimal links that should be up within the rect interface is 1. So it therefore means even if this fails, right, you're not going to have a failover to the secondary, right? Both of them have to fail for you to have a failover. Now, of course, you can change it. So in this scenario where you have 4 physical ports, right, you can say, okay, I don't want the minimal link to be 1. I mean, it depends on the traffic that is going through the link. If these are 11G link and your traffic is maybe up to 4 gig, then you definitely, or 2 gig, you definitely want to set the minimal links to 2, right? So when you set the minimal links to 2, it means if 2 goes out, or 3 goes out in this case, it means it's going to trigger a failover. Now, the reason why I'm mentioning this is, remember, previously we talked about monitoring physical interfaces, right? Was it monitoring physical? Yes, monitoring. Remember, these interfaces, we said metric weight on it, right? We said this weight is what? 255, right? Now, if this is 255, I just want us to, let's focus on, let's say we have 4 physical ports now. Now, if we set each weight here to be 255, 255, 255, 255, right? And remember, the global threshold is what? 255. The implication of this is that if one physical port fails, what happens? Because the weight of one interface is 255 and you remove it from the global threshold, remember the value becomes what? 0. So even when you have these 3 physical interfaces that are still up, what happens is the SRX is going to trigger a failover. So traffic move from the primary. Yes, this is our primary, this is our secondary. It moves from the primary back to the secondary. Okay, so the point here is when you are setting the minimal links for your rect interface, you need to make sure it matches the weight values that you also set, because these are 2 different individual parameters and they operate differently. They don't depend on each other, right? So the point here is this. So if I set one physical interface here as 255, even when the minimal link is still 3, let's say this link goes down, right? Even when the minimal link is still 2, the XRX is still going to trigger the failover. Similarly, if in this case we have, let's say in this scenario where you have 2 physical interfaces, and then we set here as 150, right? And here, let's say we also set it as 150. The implication of, let's say we set here 150 and here we set it 150, and we say minimal links, right? The minimal links that should be active in the rect interface is 2. The implication of it is if this link goes down, right? The global threshold is still what? So you have 150 minus 255, right? I think that will give you 155. I know mathematics very well, right? Not 155, that's 105. Okay? Now, this is not yet 0. So the global threshold is not triggered. But the minimal link, we said it has to be 2. So there will still be what? Failover, even when you still have one physical interface that is up. So you have the ability or the capability of setting 2 parameters that can trigger failover, and they both work independently. So most times when you want to configure such a thing, you want to configure it in an ideal way, in such a way that, yes, when one of the link fails, that when there's a failure of the physical link, it also matches what you set as the weight. Now, there's really no much other things to talk about. Yeah, I think with this we should be able to start our implementation, right? So I'm just going to pull up the EVNG topology that we'll be using. So if I come to the browser, let me delete this. And so the only thing I did in this video was that I added a new interface, right? So this is port 6 here, right? Physically it's port 6, and also added port 18. So if you'll be following in the past videos, that's the only thing I added. So I threw in one physical interface from both sides, right? Now, when you actually log into the device, you don't see port 6, but you actually see it as port 5. I don't know, it's just an if thing. of virtualization. But I think we should be able to see 18 and 19 on the switch side. So we're going to console to these devices now, and then we can just quickly configure those things. So so let me delete this. And so I'm going to console to this, and also console to the secondary. We don't really need to console to the secondary. So because they're in a cluster, and then console to this. Okay, and then let's also console to one of the servers behind the firewall, maybe this and this. Okay, so of course I'm running continuous ping here, probably did it before. We can make it small. Yeah, I can pull up the topology now and make this smaller now. Okay, so we can, I believe this should take everything out. So we can start our configuration. So I'm just going to stop this. So this is ping to the gateway, which is 10.0.0.254. So from these servers, so this is 10.20, this is 10.10, and their gateway here is 10.0.0.254. Okay, and I believe from our last topology, from our last implementation, they should be able to ping the internet as well. So let's see, you ping 8.8.8. Yeah, so they can ping 8.8.8. If we go to this device and say show chassis cluster and status. Okay, so you can see node 0 is primary for redundancy group 0 and also primary for redundancy group 1. Right, redundancy group 0 is the one link, redundancy group 1 is the local area network, right? While for node 1 is secondary, so node 1 is standby for both redundancy group. We've talked about all of this in the past. Okay, so if you go to the switch, have I considered the switch? Yeah. So I'm just going to log into the switch. No, I have to hit enter. So the switch, we're just using the default login. And if I do enable and show, let's see if we see anything from LACP neighbors. Yeah, so it's cool. So what we have here is, yeah, so we just added these two interfaces, 18 and 19. And you see, they can actually see the firewall, right, on those two ports. Of course, because you when you enable the LACP protocol on a cluster, only the active device, reply with its own signature. So yeah, so that's on the switch side. Let's also go to the let's also go to the firewall end. So if I come here and do the show LACP neighbors, so that's what I was telling you before, that so these are the new ports that we have introduced. I think I've already added them to the RETH. So I added them to, it seems I added them to the RETH 0 interface, which is wrong. So we are going to take them out. And no, it's right. Our RETH 0 is the local area network. So this is our LAN. So yeah, so all this device here is the LAN interface, and this is the WAN interface. Okay, I'm just going to undo them and put them back. I think it's just straightforward how to do that. Yeah, so let's get started now. So there's really is really not much when it comes to the configuration. So if I say show configuration interface GE0/0/5, you can see here that if you want to see the command, I think the best way to say is to say display set, right? So this is really just the command to throw them into the RETH interface, which is something we've done previously. So if I also do for 7, right? So you see both ports are now part of the RETH interface. Okay, they are part of the RETH interface, which in this case is RETH 0. So if you do show configuration interface RETH 0, we can say display set as well. So you see that there's an IP there. So that's the default gateway I was telling you about that is set, because this is the inside facing and it's part of redundancy group 1. So it's RETH 0 is group 1, while RETH 1, social configuration interface RETH 1, that should be the one link. So this is the one link. Of course, should have added a description to them. Well, this is a lab environment. So let's quickly, put them in the LACP port channel and see what happens, right? So we can continue, we can enable our continuous ping now on both devices. So this is server 1. Let's also do it for server 2. That will be on the eve. And so GNS3, I think it seems I'm already logged in. Okay, so this 10.10.10, so I'm going to say 8.8.8. Okay, so both servers can reach the internet. We can just ping something else here. Ping 4.2.2.2. Yeah, so we can reach the internet. So I'm going to go to the firewall now. It's really simple. So the first is we're going to tie the interface to the protocol, right? And then we enable LACP, right? Which is 822.3AD, I think. So edit, so go to the config mode. I'm having the bad typing. Then I'm going to say set interface RETH 0 aggregate set interface RETH 0. Then let's say the command is, let's say, redundant in enter options, and then you can say LACP. So this is not the first thing we need to do. We need to say the command should be let's say redundant options, and then we can say we just want to add it to LACP. Okay, and then we say it should be active. Okay, show pipe compare, and then we can hit commit. So it's going to apply it to both the primary node, which is node 0, and the secondary. So being that we've enabled LACP on the firewall, it should break communication to the internet. I don't expect the pings to still be going through. At some point it should stop. Yeah, now it has kicked in. So because the other side is bundling and the switch is not bundling, so there's going to be break in communication. So we just need to go back to the switch and say So previously, so a good way to see it is on the firewall. If I do show LLDP neighbors, so in this case, let me grab my pen. So we know that port 4, right? So port 4 maps to what here? So port 4 maps to port 16 on the switch, and port 4 on the other end maps to port 17 on the other switch, right? And then port 5. So what we need to do is, so here's what we are going to do. Let's try this. So I'm going to take all these ports, which is 16, 17, 18, and 19, right? And we're just going to throw them into one bundle, which is not really the Juniper's recommendation, right? So we're just going to throw them into one bundle. So what we end up having is you have here, these are your Arista buses, and this is your switch, right? Remember we said you have two interfaces here. So this is what we've done here, and then we also do the same thing here. So you just have just 2 points. So we're going to do that and see what is really going to happen. Is it going to break communication? Will it work? You know, we just see how that will play out. So I'm going to come back here. So let's do that on the switch now. So I'm going to come here and say, so let me go to the switch, and then we're going to say, so it's 16, we said it was 16, right? 16, 17, 18, 19. So interface Ethernet 16 to 19. Then we're just going to say channel group 1 mode is active. And yeah, I think that's really what we need to do. You can, what other options do you have? You can say that automatically. So show port channel summary. Yeah. So so it's up, and I can see that all the ports are actually part of the channel. That's really interesting. I wouldn't have expected that. So let's say show port channel summary, which is what we already did. Show port channel load balancing. Okay. So it's kind of weird because the last 2 ports, the port going to the secondary actually ought to be down. Well, in this case it's up, so I'm wondering why it is up. So what we can do is, do you have traffic? Can we ping? Does it mean we can ping the internet now? So I'm just going to stop this and try to ping. Now, so let's even check on the firewall and say show LACP interfaces. Okay, they are all up and distributing from what I can see. And let's say show chassis cluster status. Okay, the secondary actually ought not to respond, not to send LACP packets down to the switch. So the switch actually ought to be, but of course, you know, this is really a virtual environment, and these switches don't really behave like in the real world, because you see the switches, even when they are not disconnected, they are physically up. So that can be expected. But does it mean we can ping the internet? No, we still can ping the internet. So it means something is really not right. Okay, so what I can do is I can reboot the secondary. Let's see what happens. So I'm going to go here and then try to that's not what I wanted to do. Just want to drag it closer to, so I'm going to come here and see, let's try to reboot the secondary. Request, I'm seeing some messages here. I want to see what this message is. Okay, so I'm going to say request system reboot. let's see what happens when we do a reboot. So when we do a reboot, the LACP interfaces on the switch some ports should be done now. Okay. This is the firewall. I'm talking about the switch. So let's check the port channel summary again. If this is up, that tells you something is really not. Of course, there's a default timer. So let's see what happens. So another thing I'm trying to check here is I want to be sure that the configuration is right, because when you say set interface RETH 0, let's see the options I have. I'm looking for something that has to do with I was expecting you have a place where you tie in the okay, so it seems it's working now, right? So it started working, whereas so let's see what happens to, let's see. So you see now the connection that goes to the secondary is actually down, right? So I think what was happening was that, but even at that, some traffic should have gone through. So like we said, when you have a switch, when you have a firewall, this is your SRX B and this is SRX A, and you have your switch, and then right, and then let's say this is one bundle. The question is, when you make this one bundle, the implication of this is when this server send traffic to the switch sees these devices as one, so it's going to send some traffic here and some packets here, right? So what I would expect is that you have some packet drops, right? Because some traffic that comes through this part will be dropped, if at all. Here is up, which is not even supposed to be up in the first place, but you know, in our lab it's off for some reason. So what we're having is, if you send, let's say 4 packets, you can have like 2 packet drops and 2 will go through, right? That would have been my expectation, right? But in this case, for some reason, these ports were still up. I don't think when you use the hardware devices, you're going to see anything like this. So now let's wait for the secondary to come back up. It's still down, but of course we have connectivity to the internet, and when you say show LACP, so it's run show LACP interfaces, so you see just 2 ports are actually distributing. So what we need to wait for now is, if the secondary comes back up, is it going to bring back the port channel? If it brings it back up, then we have to come to the switch and then change the port channels. So we need to create 2 separate port channels, which is actually what Juniper recommends. So I'm going to come here and say admin root and my passwords CLI, and then show LACP interfaces. So it's going to take a while for it to come back up. So I'm just going to pause the video a bit just to get the device ready. So hi everyone, the device has rebooted and it took a while. It took about up to 15 minutes or more. I probably this is virtualization, but what I noticed was that let me look. If I do show LACP interfaces here, you see it doesn't really show you that LACP is running. That doesn't mean the device is not up. It's just because it's the secondary at the moment, so it's the primary that will usually display that. But if I say show LACP interfaces, so you see all the port has started distributing again. It's distributing, and if you go to the switch The switch tells you, oh, my port channel is up and all the ports are part of the aggregate. But when you check, there is no traffic. Okay, so for whatever reason, we can't ping. So I think the best thing is to do is to follow the recommended implementation. So we're going to go to the switch, and then we're just going to move these two ports. We're going to move port 17 and 19 to a different channel group. So I'm just going to come here now and say config T. I'm going to say interface Ethernet 17. So I'm going to say channel group will be 2, and then the mode is active. All right, and then we also do the same for Ethernet 19. Then we're going to just use the upper key. So they are now part of a different port channel group. So if I say port show port channel show port channel summary, you see they are all part of different port channels now, right? And so I think the PC, so we are now able to reach the internet. Something we also need to enable is so on the switch we need, so for you to, if you want to fast track if you want to increase the timers for the LACP, you need to enable periodic fast, right? So I'm going to just do that here. I'm going to say config T interface range, no, it's not spotted, interface 16 to 19. I'm going to say LACP timers is fast. So this is the command to enable fast LACP on the restart box. So we also need to do it on the SRX. So I go to edit. If I say run show configuration interface rect 0, which is yeah, so display set. So we can add the LACP fast here. So the command will be something related to this, not this. So this should be the command LACP periodic fast, right? So we're tying it to the right interface and not the physical interface. So if I say show pipe compare, commit and quit. Okay, so we've enabled fast hellos here. So if we say, so if I come here now and say show LACP interfaces, you should see it's now periodic, fast periodic. I think previously it was slow. Yeah, so previously it was slow periodic, right? So now they are now aggressively sending LACP hello messages on both sides. So what we can do now is if I do a reboot of the primary, I don't want to reboot because it takes too much time for the system to recover. I'm just going to shut the port down here. So I'm going to say edit. I'm going to say set interface GE 0/0. So it's port 4 and 5 definitely. So set interface GE 0/0/4. I'm going to disable this end. So I'm going to disable 4 and 5. All right, show pipe compare. I'm going to hit commit. So this should automatically shut down the connection from the touch switch to the primary device. So if I pull up so these two connections is what we just brought down. So let me grab my pen again. Okay, so these are the ports we just shut down now. So I just brought this port down and this. So the expectation is that the traffic will go through the secondary for that redundancy group. So one way we can test that is to say, so I can come and say, let's see, exit. So I'm going to say show chassis cluster status. So I expect you have a failover to the secondary. So the one needs to be primary for redundancy group 1. So let's see. It's not failing over, but it should fail over. It's taking a lot of time. It should fail over to the primary. So let me say let's look at the configuration again. Show configuration for, let's say, chassis cluster and say display sets. So I know we are doing monitoring, yeah. So we set it to 255, but of course we did not set the weight for the new interface we just added. So let's also set that here. So I'm just going to use one of these. So if we are monitoring the physical interface, it should trigger the failover, right? So we're not monitoring. So let's just add that here. So I'm going to say port 5, and the other one is 7/5. Okay, so commit. So show chassis cluster status. It still did not fail over. The primary is still on, but I expect redundancy group 1 to fail over to the secondary when the physical ports are down. Is it not down? So let's say show interface status. Yeah, ports, they are both down. I just want to quickly show you the it wouldn't even show here. So I'm seeing the RECT interface. I was expecting that I will also see the AE interface that we just created. It's not showing here. So, but if we say show LACP, if we say show LACP interfaces, you see that yes, these ports are no longer part of the bundle, right? But this is now up, right? This is now up. It was up before, so traffic ought to fail over to the secondary, but for some reason it did not fail over. So show chassis cluster status. It still did not fail over. Probably the hold on time, I don't remember what we configured then, how long it has to wait before it fails to the secondary, but at some point it should actually fail to the secondary device for redundancy group 1, right? Because if you do check the show configuration chassis cluster, right, display sets, we did say that for redundancy group 1, node 1 is 100 and node 0 is 200. So when the port goes down, let me see, even the hold on timer is 1. So when the physical ports are down, which in this case they are, we expect traffic to fail back to the secondary. Yeah, so another way to do is just, initiate a reboot. Let's say request system reboot. Of course, it takes the whole year to reboot. So I'm going to say request system reboot, hit enter, and yeah, so there's a reboot of the primary now. So I expect the routing engine to move to the secondary, and you see it automatically. Now, in this our implementation, of course, these are no physical devices, right? And yes, so that could be the reason why we are having these issues, because when you shut the two physical ports down towards the LAN, traffic should actually move over to the secondary for redundancy group 1, which is based on our previous implementation. So now we have a reboot. The routing engine should have moved to the secondary, which it has. So you see only these ports are up there. It was a little bit fast compared to before because of the LACP fast timers that we implemented. Now, yeah, so the last thing I want to quickly add to this is that for if I do show configuration, say chassis cluster, then let me just say display set, show chassis cluster. Let's just say display set, show interface, show configuration interface for RETH 1, and then say display set. Not this is not what I'm looking for. I'm looking for show configuration in let's say show configuration chassis cluster, right? Display sets. Now there's a command here that I added. Is it even here? It's not here. So that command was tied to, let's say show configuration interface RETH 1, then by display set. Okay, could it be there was no replication to the secondary? I'm really not sure what is going on here now. But what I wanted to add is, remember we talked about setting minimal links. Let's say show chassis cluster status here. Run show chassis cluster status. Yeah, so here's the primary for node 1 is not primary for both redundancy group. So if I say show I wanted to talk about setting the minimal links. So if I say set interface RETH 1, right? Show set interface RETH 1. I think it's redundant and options. Then here you have the option of setting the minimal links, right? Here you need to set, okay, how many physical interface should be up in the RETH interface for it to still be up, right? Here we can set it to be 1. So when you set this and you shut down the RETH interface or the physical port, then it should also trigger a failover for that redundancy group. So I'm going to just put it as 1. I'm going to hit commit. So what this means is that if you have two physical ports in a RETH interface and the 2 goes down, this could also initiate the failover to the other device in this case. So the device is still rebooting, and we still have connectivity to the internet. So let's go to the switch now and say show port channel, show port channel summary. So you see the port channel to the primary is still down, and the one to the secondary is up. Okay, so the expectation is that when this device is back online, let me log in, CLI, show LACP interfaces. It's not running. Remember, the secondary will not relinquish its role as the primary for redundancy group 0. The routing engine does not automatically move. So if we want to move it back to the primary, we'll have to manually do that. But what the command I want to set here is I wanted to say so if I should, there's something I wanted to implement that so our pings are still going through, so I need to bring those physical ports back up. That's what I wanted to do. So I'm going to say set interface GE0/0/0/4 disable. So we need to delete this config. And then we also need to delete it for the other device, so which would be 7/4 sorry, 7/5 so we didn't do this for this, so we really needed to do it for 5. Show pipe compare. So hit commit. So this should bring back the physical port on the primary node. So node 1, the configuration is applied to node 1. I'm not sure if it has established connectivity. It says, so let's do it again. All right. So the configuration was only committed to node 1. Probably there's still no show chassis cluster. Show chassis cluster status. So node 0 is back online, but the configuration is not yet. It's just not ready. Okay. So because it's not ready, most of the configuration will not be sent to the primary, but as soon as it's ready, they should be able to. So let me see if I can request chassis failover, cluster failover. Then you can see node 0. So we are for redundancy group 0. So here we are moving. So it's not, because the device is not ready, we can't failover. So if I say show chassis cluster status, it should see, it's still going to take a while, but I hope we're able to get one or two things from the implementation, even if it did not really go the way we want. Of course, we have limitations because we are not using physical devices, but this is really how you can, configure LACPs for RETH interfaces within your Juniper implementation. Okay, thank you for watching this video. If you like this video, you want to see be able to see more videos like this, you want to subscribe, like, and share. And I see you in the next session where we start diving into IPsec VPN for Juniper devices. Thank you, and see you in the next video.